आईडी कार्ड मिला है ना, डाला है गले में, सबने डाला नहीं मिला, किसको दिया नहीं अभी और रिपोर्ट कार्ड भी मुझे सबमिट करने का आप लोगों ने एक जेरॉक्स लेके आ जाओ नेक्स्ट क्लास में ट्यूसडे को। सर यहाँ पे बैठ जाओ।
अटेंडेंस दिया है क्या? हाँ मैंने, हाँ ये वही अटेंडेंस ये देना है ना? हाँ.
Good evening, all of you. Okay, so it's full house. Very good. Do we have online students?
ये आएगा राजू
Rajveer, okay.
शायद ये मेरे लगेगा.
ठीक है, तो उसको मैं ले लो ना. दे दो. 2 में हो. I have to keep my water bottle from there. ठीक है. I would request to leave this table, huh? Because I'll need space to keep my book. This is full house. या इस पे 3 बैठते हैं, क्या करते हैं? एक जगह खाली है. You mind shifting there? हाँ ठीक है. No, this will be very cramped. Sit with 2 people, or you come here. Let both of them sit there. Is that okay? Is that okay? 2 of you can shift there. First, you come out. Let him come out first. Come out here. Let them go. Now you sit on the second. So this bench will be reserved for me. Okay. All right. So Most of you, I think, are familiar with me. Those who are new joinees, my name is Uday Singh, and I'll be covering the physics portion of your science syllabus. Okay, so I'll be starting with light. That's the chapter. This is chapter number
9.
So let us start by understanding what is light. Anybody? What is light?
Light is a form of energy that creates sensation of
Correct. So sensation of
light.
sight. Okay. Visibility. Okay. So it is a form of energy that creates sensation of visibility. In short, light helps us see things around us.
Yes.
So how do we see things? Let's say you're able to see this pen. How are you able to see this pen?
Reflection of light.
So if I switch off all the lights, will you be able to see?
No.
No. So what is happening? Some light is falling on it, then it is reflecting that light. Okay? And it is because of the reflected light you're able to see this. So the reflected light is carrying the optical info. So, and we know that light travels in straight line path. So is everybody able to see this pen?
Yes, sir.
That means light is traveling towards you. It is traveling towards you. Can everybody see everything of it? So back you can't, obviously, because it is opaque. Okay? Because it is opaque. That's why you can't. If it was a glass rod, you could have seen the back portion. So basically, whatever portion you are able to see, everybody is able to see. And each part you are able to see. That means light is reflected in infinite directions. Okay? Anybody hanging on the floor, on the roof, also will be able to see. Anybody sitting on the floor is also able to see. But we will see that for simplification, we require only 2 light rays for image formation. Basically, why you are able to see this is the object, its image is forming on your retina, eye is retina. So in this chapter, we are going to learn about what are different types of images, how it is formed, how to draw the ray diagram of image formation. Okay, all those things we are going to learn. Okay. So next is we see things when light falling on the object is reflected and reaches our eyes. Okay, so to see things, we need two things: light and the reflected light, source of light, and the reflected light from the object that must reach our eyes. Only then we'll be able to see. Okay. This reflection. Now let us understand more about reflection. What is reflection of light?
When light bounces off the surface.
Bounces back in the same medium from where it is coming. Okay. So it is bouncing back of the light in the The same way. Okay. Now, let us discover some more properties of light. Then we'll come back to reflection again. Some properties of light. What is light? It exists in the form of yes. Which wave? Electromagnetic wave. So light wave is a form of electromagnetic wave, right? Means whenever light wave is traveling, it has electric and magnetic field energy around it. Okay, electrical energy as well as magnetic energy, and the visual sensation is because of the electric field. So we're going to learn about it in more detail in higher grades, but right now you just understand that it is electromagnetic wave. Now, if it is electromagnetic wave, it travels with what speed? It travels with 3 into 10 raised to 8 meter per second. Where? In vacuum. Yes, in vacuum. So we say in vacuum, and we also treat air as vacuum only. It will be slightly less in air. Okay. So air or vacuum, you treat it as 3 into 10 raised to 8 meter per second. In all other transparent mediums, so for light to travel, the medium has to be transparent, like glass, water, etc. So glass, water, air are 3 transparent mediums. So in all other mediums, speed of light is less than 3 into 10 raised to 8 meter per second. Okay, only in vacuum and air it is fastest. In all other mediums, it will be less. So then light travels in straight line. So the path of light is called ray. The path of it's called ray. Okay. But generally, if it is a laser pointer, okay, then it is one line, right? But if you have a torch, any other source, so it is not just one ray, so many rays are traveling together, then it is called beam. Okay. So bunch of rays traveling together is called beam of light. It's called beam of light. Okay. So this is all properties of light. Are online students able to hear me properly?
Yes, sir.
And can you see whatever is written on the board?
Yes.
Okay.
Yes, sir.
Okay. Now we said that we are able to see objects when they reflect light falling on them. Okay. So this reflection, there are different types of reflection. First, let us learn about laws of reflection that you already know. Laws of reflection. So reflection of light always obeys laws of reflection. Okay. So you're familiar with the plane surface, reflection of light by a plane surface like a mirror. So what do? We first draw normal. And then let us say a light ray is incident here. So this is the point of incidence, and we draw a normal at the point of incidence. And this is our incident ray. Okay. And whatever angle it makes with the normal is called angle of incidence. So as per law of reflection, the angle of incidence is equal to angle of reflection. So this is the first part of the law. Angle of incidence must be equal to angle of reflection. And what is the second part of the law? This is a reflected ray.
The reflected ray, incident ray, normal and reflected ray all lie the same.
Exactly. So the incident ray, the normal and the reflected ray at the point of incidence lie in the same plane. So what I mean by this is all these rays are in the same plane. Does it make sense to you? See, for example, assume this is the reflecting surface, okay? And this is the vertical plane, right? So if the light is incident here in this plane, this is the vertical plane. If the light is incident in this plane, then it will be reflected in this plane only. So if I rotate this plane like this, keeping the point of incidence same, now the light is reflected in this plane. Understood? So this is the plane of incidence. If the light is incident like this, it will be reflected in this plane. If the plane is turned around about the vertical axis, now light is incident here and it is reflected in this plane only. So the incident ray, the normal and the reflected ray, all of them has to be in the same plane. Okay. All right. So the incident ray, I am using a shortcut, but you have to write the full form. Okay. IR is incident ray, the reflected ray, and the normal at the point of incidence lie in the same plane. So this is the law of reflection that you are already familiar with. Now this is the reflection of light by a smooth surface. Irrespective of the nature of surface, this law is always obeyed. What if it is a rough surface? Like a wall. Is wall smooth like a glass? No. So it will have irregularities. So if you magnify it, okay, so reflection by rough surface. So let's say you have a rough surface like this. So it will have cavities and some irregularities like this. Okay. So you'll have some curved portions. Right? So what do we need to draw the reflected ray? We require a normal. Right? So on a plane surface, the normal is just a perpendicular at the point of incidence. How do we draw normal here? So at a curved surface, what is the normal? Right? So if you look at this, these curved surfaces may be assumed to be the part of some circle, right? So if this is the point of incidence, then the normal is the radius actually. Normal is radius. For any curved surface, the normal is radius. and normal is an imaginary line. So all imaginary line has to be dotted ray. So this imaginary, this is real ray, okay? But normal is imaginary line. So it has to be dotted ray. Is that understood?
Yes.
Now here, so for this the circle is on this side. Right? This is the part of curvature of some circle. Now what is the normal in this case? So let us say this is the point of incidence. Now here normal will be like this. Okay. Now look here. What is the difference? On a smooth surface, let us say we have different incident rays. Let's say 3 incident rays. So they will all the incident rays will be parallel to each other. And they will hit the surface at different points. Okay. Now everybody will have their own normals at the point of incidence. Now you can draw the reflected rays. What do you see here? The incident rays are parallel to each other, as well as the reflected rays are also parallel to each other. So this kind of reflection is called regular reflection. Regular reflection. Okay. Now what about this case? Now let us say the incident rays are here. One point of incidence is this. The other point of incidence is this. Right? And so incident rays are going to be parallel. Okay, so the incident rays are parallel. Now look here, by law of reflection, I have to construct reflected ray equal to angle of incidence with the normal. So here, this is the reflected ray. But for this case, you see the angle of incidence is now small. Here the reflected ray will be this. So although the incident rays are parallel to each other, but reflected rays are not. Okay. So if you take one more ray, this will go somewhere else. So such kind of reflection is called irregular reflection. When the reflected rays are not parallel to each other, so this will happen during reflection by rough surface. So such reflection is also called as scattering of light. What is it called? Scattering of light. Okay. So what have we learned in this case? For curved surface, the normal is radius. Curved or spherical surface, the normal is radius. Or it is perpendicular to the tangent. Okay. So at this point, are you familiar with what is tangent?
Yes.
Okay. So at this point, you draw a tangent. There is only one tangent possible at a point on a circle. Okay. So once you draw the tangent, then the normal is perpendicular to that tangent for a curved surface. Is that clear? So that's right. Okay, for a curved surface, you'll have one radius. So that radius itself will act as normal. You extend the radius across the surface. Why we need normal? To draw the reflected ray. And whether the surface is smooth or rough, at the point of incidence, the angle of incidence has to be equal to angle of reflection. Yes. Any questions on regular and irregular reflection, laws of reflection, and how to draw normal on a plane surface and on a curved surface? I think it should be clear. Now let us learn about properties of image formed by plane mirror. So imagine we have a plane mirror. So let's say this is the object here. Now I want to draw the ray diagram for image formation by a plane mirror. So what do I need to draw the image? I require two rays, like I said. So this object will emit infinite rays. Okay? Focus here. Any object, as we discussed, will emit infinite rays. But for making the ray diagram for image formation, we only require two rays. Okay? So let's take these two rays. Let us say these are the two incident rays. So to draw the reflected rays, right, I need a normal. So this will be the normal for the first point of incidence. This will be another normal. So this is I1. Now you construct the reflected ray equal to angle of incidence. And here the angle of incidence is bigger. So the reflected ray also will be bigger. Right? So now these rays are diverging. Reflected rays are diverging. So what should happen if somebody is watching or standing here in front of the mirror to observe the image of this object? What will he see?
Rays are coming from a point behind.
He will feel that the rays are coming from somewhere here. Okay. This is how he will feel. So this will be your O dash. So this is another ray you can take, the third ray. Now this is along the normal. So it will be reflected back. Because angle of incidence is 0. So So all these rays will actually converge here. Okay, straight line. So straight line. This is Udays. So anybody seeing from this side will feel that these rays are coming from this point. But are these actual rays?
No.
No. When the reflected rays are extended backward, they will meet at a point. So at that point, the nature of image will be virtual. Okay. So what kind of image is formed by a plane mirror? Virtual image. So virtual image is formed at a point from where the reflected rays appear to diverge from. Okay. So this is where the virtual image will form. Now what is the other property of the image? It is at the same distance behind the mirror as the object is in front of it. Where is the image position? Image is at same distance behind the mirror as the object is in front of it. Okay, this is the second property. What is the third property? What about size of the image?
Same size.
Same size. Image size is same as object size. Fourth property. It is laterally inverted, correct. Image is laterally inverted. Laterally, just check the spelling. Is it single T or double T?
Single T. Single T double L.
Inverted. What is the meaning of lateral inversion?
Right will appear, left will appear.
Okay, left, right, horizontal flipping. Okay, that is left becomes right and right becomes. Okay, so like if you're seeing the image of letter E, the image will be like this. That's why ambulance, it's written laterally inverted so that the driver in the front vehicle sees the image, which is, he will be able to clearly read ambulance. Okay, so that's what it is. Then what is the other type of image? Here we have taken 3 ray diagrams. If you did not draw this ray, then the point is this only. Okay. So minimum 2 rays are required. Maximum you can take as many. Is that clear? You got the idea how to draw the image? You can draw the image with the help of only 2 rays or more. Up to you. Minimum 2. Okay. So far is revision only. You are familiar with image formation by plane. But in this chapter, we are going to do image formation by spherical mirrors. Okay. So that is what you are going to learn here. So are we good till here?
Yes.
Okay. So we know that virtual image is formed from where the reflected ray appear to diverge from. There is another type of image called real image. Real image. So at what position real image is formed? It is formed at a point where the real image is formed. Yes. Here the reflected rays are diverging, but in case of real, the reflected rays will converge at a point. So wherever the reflected rays actually intersect each other, that's what the real image will be. Okay, now there is another property of virtual image. It is upright. Okay, virtual here and erect. So like if you are seeing yourself in the mirror, you will see yourself upright only. You won't become like this. Okay, but it will be flipped. It is lateral inversion, not vertical inversion. Okay, that's why it is erect. It is formed at a point where the reflected rays converge or physically intersect each other. Intersect. The other property of real image is that it is always inverted. Okay, so the property of virtual image is it is always erect, whereas real image is always inverted. What is the other differentiation? Virtual image is always behind the mirror, whereas real image will be in front of it. Okay, real image is always formed in front of the mirror. Okay, and virtual image is behind them. Which side is front and which side is behind? The incident rays are always in front of the mirror. The side of the incident rays is front. So this is front. Okay, this is behind. The silver coated side is behind them. Okay, and the polished face is front of it. Is that clear? So what? Where is real image formed? In front. Where is virtual image formed? Behind. Okay, just keep these minor things in memory, and then this will be clear when we'll discuss image formation by spherical mirrors. So, any questions still here? Let's discuss image formation by spherical mirrors. Going in order. Am I really? This is only. Acha, you're not able to write. Okay, so write it down. Have I erased anything that you could not complete? So my suggestion is don't use scale and pencil. Use a freehand diagram. Okay, so that you'll be able to write faster. Don't use scale right now. Just catch the logic. Okay, and make sure that angle of incidence is equal to angle of reflection. Because if you start using scale and all that, it will take. Arrow is a must everywhere. In ray diagram, arrow is must. Everybody please take notes. Angle of incidence, angle of reflection. I1, R1, I2, R2. Yes, always. Law of reflection is always the same. For every incident ray, the reflected ray has to be equal to. But different incident rays may have different angle of incidences. Yes, whether rough or plane, law of reflection is obeyed at the point of incidence. At the point of incidence. But the reflected rays may not be in the same direction for a rough surface. Whereas for smooth surface, it will be. Or without normal now see, so it should be logically correct. This distance and this distance are not equal. So here you draw normal for this ray, so there is normal for this ray. Every point of incidence should have a normal. Now this is a rough surface. How can the normal be parallel? This is a curve, so it should be along the radius. Okay. Read the diagram. Right here in the this is one radius. This is not correct. Here from normal this. So we can the radius to the curve. So everybody keep taking notes, right? I'm saying not everybody is taking notes. Yes.
Sir, can they be clear?
No. Then it is not. So that's not the property of real. Real has to be inverted. Virtual is correct. Okay. Is that clear? Real events has to be necessarily inverted. And virtual has to be necessarily correct. It will become clear. We are going to discuss so much about it. Online student, do you have any questions?
No, sir.
Okay. So let us proceed further. Can I erase now? Have you?
Yes, sir.
So we are actually starting now. So far was basics. So what are different? What is a spherical mirror? These mirrors are obtained from hollow glass sphere. Okay, that's why they are called as spherical mirrors. Suppose you have a hollow glass sphere like this. This is a hollow glass sphere. Okay. So it will have a center. Right. Now you make two cuts here. ठीक है? So sphere में से you cut along the sides. So now you have got, and then do the silver coating. You do silver coating here. And here you do the silver coating this side. Right? So what are two different types of mirrors you got? Okay, you got two different types of mirrors. So why they are called spherical mirror? Because they are obtained by from a sphere. Okay. So this is called convex mirror. And this is called concave mirror. What is the difference? The reflecting surface is called inwards or concave mirror. So here reflecting surface is curved inwards. Right? For convex mirror, the reflecting surface is bulged outwards. Okay. So now let's become familiar with some terms associated with spherical mirrors. First is C. So every spherical mirror will have a center of curvature. First is center of curvature. And what is center of curvature?
Center of the sphere.
Yes. It is the center of sphere around which or of which the spherical mirrors are part of. Okay, so center of curvature is denoted by C. Next is pole.
Is the center of the spherical mirror.
Yes, it is the geometric center or the center of the mirror. So this point lies on the mirror. Okay, so it will be like a bowl. Okay, from the sphere, if you cut a mirror, or like a spoon. Everybody has seen spoon. So spoon has two surfaces. One the bulged out, the base, and one is the inner surface. So the inner surface of the spoon is convex mirror, and bulged out is inner is concave mirror. Bulged out is convex. Okay. So when you rest the spoon, it will touch at some point. That will be its pole. Now spoon is not a perfect. It's not a curved surface perfect, it's like oval shape. Imagine a circular spoon. Okay. So this is called pole. So it is the
Center of space.
Geometric center of the spherical wave. Okay. So you have a pole here. So so if you pass a line from C to P, this is called radius of CP. Okay. Okay. So let's first do principal axis. So line
Center of current.
passing through C and P. So principal axis is the line passing through C and P. So this is principal axis. Principal main, okay? It's principal axis. Then you have something called as center of curvature.
So done.
Sorry, radius of curvature. So it is symbol is R.
C and P.
It is length CP. Length
CP.
CP or PC you should say, because all the lengths are measured from pole. Length PC. Okay. So that is called radius of curvature. It is nothing but the radius of the sphere of which the mirrors are part of. Okay. Then you have focus. Principal focus. So what is principal focus? It is the point on the principal axis, okay, where the incident rays parallel to principal axis converge after reflection. Okay. So what is principal focus? So, for example, you have this concave mirror. This is P. This is the first step of ray diagram. You draw the mirror, mark P, mark C. Now let us say you have some parallel rays incident from a far object, such as sun. Sun is very far away. So all the light rays coming from sun will be like traveling in one direction. So it will be parallel. So now what are the point of incidence here? This point and this point is the point of incidence. So what is the normal here? Line joining C. From the point of incidence, join the center. Radius is the normal, right? So this is the normal. Once we know the normal, then we can draw the reflected ray. So construct equal angle on the other side. You will find that it exactly cuts the principal axis at the midpoint of CP. Here also, it will cut it at okay. Now everywhere we will not be drawing the normal. It is understood that if the ray is parallel, it will cut somewhere at the midpoint, and that point we call as focus. Understood what is focus?
Yes.
So it is the point midway between C and P on the principal axis. So principal focus, I'm writing it here. it is the point on the principal axis where the rays incident parallel to the principal axis converge after reflection by the spherical mirror. Okay, this is in case of concave mirror. We will see for convex mirror, after reflection, it will appear to meet at the point on principal axis. We'll see that. Okay, is that clear? So note, F lies midway between P and C. Okay, so it is half of, so length. So this length is called focal length. That's next. PF is called focal length. That is next. So we'll cover that after the break.
I waited for you. Such a long time. You saw many things, right? मैं चल के आ रही हूँ पूरा. हाँ. चक्कर पे उधर के गेट से इधर के गेट उधर के गेट के आया. सुनेगी मेरी बात. तेरी गेट से तेरे बिल गेट तक 3-4 बार डाउन मारे.
So applies midway between B and C. So now let's discuss.
Pole or vertex or pole of the mirror same.
Pole of
Pole or vertex and pole of the mirror are the same.
pole or vertex.
Pole of what? Pole or.
Where is pole of vertex? Show me. Use pole. Vortex are not seen. Around this direction. Okay. Use pole or just it means the same thing, but just use pole. Don't use the vortex in answer. Then you follow इसमें कुछ extra चीज दिया हुआ है. So pole, whatever I am giving you pole. ये भी पब्लिक स्कूल बहुत रॉयल आदमी यार हाँ ओके F lies midway between P and C. Now this we have discovered for concave mirror. Now let's see what happens to convex mirror. Now for convex mirror, the C will lie behind the mirror. Center of curvature will lie behind. And if you have incident rays like this, so where is the normal?
At the center of the normal is from center of the
Not pole, point of incidence. Center of curvature to point of incidence. Got it? Okay. So now what is reflected ray? Light has to be reflected, so it will be reflected in this direction, making equal angle. And this will be reflected in this direction. Okay. So when it is extended backward, you will find that it will somewhere right here. So irrespective of whatever is the type of mirror, this reflected ray will either appear to diverge from focus, or in case of concave mirror, it will converge after reflection. So here the nature of images are different. This is a real focus, and this is virtual focus. Okay, understood? So the image formed is virtual here in this case. But otherwise, PF is equal to FC. F lies midway. So in this case, it is the point on the principal axis where the rays incident parallel to principal axis converge in case of convex mirror, or appear to diverge from in case of convex mirror. Is that clear?
Yes.
So this completes it. Now next is focal length. This symbol is small f. Now what is focal length? Focal length is PF. Length. It is length PF. That is distance of focus. Focus is also referred to as or focal point. Focus, principal focus, focal point, one and the same thing. Then here, that is, this is the focus from pole of the image. Is that clear? What is focal length? Distance of focus from pole of the mirror. So relation between F and R. So this length is half of this length. PF is half of PC, correct? So F is equal to R by 2. It is always obeyed. Sometimes in numericals, the radius of curvature will be given. So then you have to calculate the focal length by dividing it by 2. Clear? This relation is always obeyed, irrespective of any type of mirror. So with this, we have completed all the terms related to mirror. Aperture, yes. So what is aperture? Now look here. This point, let's call this as M, and this is N. So it is the diameter of the circular edge of the mirror. Okay. So aperture decides the exposure area. The incident light cannot be more than the aperture. Okay. So aperture is the, where should I write? Can I erase this?
Yes, sir.
So aperture it is the diameter of the circular edge of the mirror. See, if you see a physical mirror, right, it will appear to you like this. Okay, like a bowl. So what is aperture? Aperture is this diameter of this circle. So this is the circular edge of the mirror, and this is aperture. This is silver polished. Is that clear? So aperture is mm.
Sir,
Yes.
that MN is not tan.
That mn is
Not tan.
not.
Tan.
It is diameter.
So diameter should pass through two centers.
This is the center, no? This center is pole.
Center of the curve.
This is a bowl, right? Bowl has a base and also the edge. Lemon, cut it in half. So the one is the curved surface of the lemon, and then the plane surface. That is aperture, diameter of that. Are you getting it?
Sir,
Yes or no?
in that diagram you will
The lower diagram.
See the perspective, visualization, 3D image it is. This is 3D. Chinese soup bowl, imagine that is the mirror, spherical mirror. So how is the structure of the soup bowl? It will have the brim, no? Brim. The brim will have circular face. That plane, so that diameter. No? क्या problem है हिंदी में बोलो?
Sir, that diameter should pass through that center.
Which center?
So
ये diameter नहीं है वो. ये
That
diameter.
diameter should pass through center. It is not passing through center.
Why it should pass through center? You mean here? ये इसको आधा करेगा तो जाएगा सेंटर से.
हाँ सर, तो फिर वो diameter बोलेंगे इसको. अगर जो center से नहीं जा रहा है तो वो chord हो जाएगा.
Diameter of the circular edge. जरूरी थोड़ी ना कि तू पूरा कटोरी जैसा मिरर लेगा. Mirror is only half cut, not मतलब partially cut, not exactly through the center. You understood? This is what was your this thing, that it should be cut. Where have I cut it in the center? So circular edge कहाँ पे बनेगा? यहाँ बनेगा ना? Where will be circular edge? In 3D, you visualize it in 3D. It will be hollow ball. So this circular edge. Are you with me? घर जाके एक दो नींबू कट करो. नींबू का जो एज है सर्कुलर उसका डायमीटर. ठीक है? Okay. So aperture decides the exposure area. You cannot have incident ray more than the surface area of the circular edge. उससे ज्यादा लाइट इंसिडेंट नहीं हो सकता. तो अपर्चर छोटा करोगे तो लेस लाइट विल बी इंसिडेंट ऑन द मिरर. ठीक है? ओके. नाउ विल डिस्कस इमेज फॉर्मेशन बाय स्फेरिकल मिरर्स. आर वी गुड टिल हियर?
Yes, sir.
Let's discuss image formation by so how many rays we need to consider for image formation?
Minimum 2.
Minimum 2. So what are the possible rays for image? Any two. So how many rays we need to consider for image formation?
Minimum 2.
Who has a doubt? Rajveer, you have a doubt?
No, sir.
No, speaker is muted. Rajveer, you had a doubt?
No, sir.
So ये speaker सुनाई नहीं देता. Wait, say that again, Rajveer.
No, sir.
अभी नहीं बोल रहा है, पहले बोल रहा था है. और खाएगा. Okay, so why echo came? Any two rays from the following rays can be considered or too much noise. So what is the first ray? Ray incident parallel to the principal axis. Passes through focus after reflection. Right? So you're familiar with this.
Yes.
The reverse is also true. Ray incident along focus, okay, becomes parallel to principal axis after reflection. Ray incident parallel to principal axis passes through focus. Following rays can be considered for image formation. Considered. So ray incident along focus becomes parallel to principal axis after reflection. Okay, this is the second ray. Third, ray incident at pole. What will happen? It will reflect, making the same angle of incidence below. It will reflect by angle equal to angle of incidence, but now below the principal axis. Ray incident at pole. Why it is so? Because principal axis itself is normal. Because it is coming from Cp. Cp is radius. So radius is normal. Gets reflected making angle of reflection same as angle of incidence. Okay. Fourth,
You're written angle of making angle of
angle of reflection, same as angle of incidence. Okay, I had written it once. Fourth, ray incident along center of curvature
We pass through center.
will
Coaches.
retrace the path because center of curvature is normal. Okay, ray incident along center of curvature. Ray incident. काय चल रहा है? Ray incident along silence center of curvature retraces the path after reflection. You see, everywhere the word reflection is appearing. So one is incident ray, and then you have reflected ray. So from these four rays, you can choose any two. So this is a must. Okay. And then from the remaining one, depending upon the convenience, you can choose any one more. Okay. So any difficulty in understanding this? let's start the ray diagram. So image formation by convex mirror first. Sorry, concave mirror. Yes, you have to draw. Huh? Yeah, you just catch the logic, and then while practicing at home, you can do that. Otherwise, here you may take more. Why concave mirror? So there are 6 object positions for concave mirror. First is
At infinity.
when the object is at infinity. Very repetitive steps. Okay. First thing what you will do is you draw the mirror and then draw the principal axis. This is the first step. Then mark pole. And then this silver coating. Now mark center of curvature and focus. So let us say you have taken this as 6 centimeter, then focus will be at 3 centimeter. Okay. So you can just use unitary method. So if C is at 6 centimeter, F will be at 3 centimeter from pole. So just draw the proposed. We'll come to sign convention. First you do the image formation. Okay. Now, when the object is at infinity, what did I tell you? What is the nature of incident rays? Parallel to principal axis. Whenever the object is very far away, so the object will be very small and all the rays will appear to be coming parallel. Okay. So for object at infinity, the only choice of incident ray is parallel. So we know if the ray is incident parallel to principal axis, passes through focus after reflection. This is the rule now. These are now rules. Ray incident parallel to principal axis passes through focus after reflection. So now I need not draw normal. No need now. Okay. So I draw it through the focus. So don't draw this F because sometimes the rays might cut over it. So first you complete the ray diagram, then do the labeling. Okay. So when the object is at infinity, now you have to write the properties of image form. Okay. So what properties? First you have to write the image position. So image position, where is image position?
At focus.
Image position at F. Image at F. F means focus. Then what is the size of image?
Point size.
Size is
Point size.
highly diminished or diminished to a point. Highly diminished. Highly diminished or diminished to a point.
Sir,
Yes.
sir, how can we identify that the image will be diminished?
Because it is point no. And this, sun, it is so big. But what about this? The image is coming as a point on the principal axis. You can actually see for yourself practically, right? So it is diminished, right? Real and inverted. Why? Because the reflected rays are physically intersecting. So what is the nature? Nature is real and inverted. ठीक है? So these are the three properties of images: the image position, image size, and nature of image. For every object position, you have to mention these three things for all cases. Okay. So what is the image position? At F, size is highly diminished or diminished to a point, and nature is real and inverted. Okay. By default, it is real because I can see rays are physically intersecting. And if it is real, it will be inverted. It will become obvious in the next case. For this case, since it is a point, you don't know whether it is inverted or not. But in the next case, it will become obvious. Okay, let's draw the ray diagram for the next case. Case 2. Now see, for the first case, object was at infinity. Now where will be the next position? Beyond C. C के पहले इधर. Beyond C. Then next will be at C. Then next will be between C and F. Then next will be at F. Then last will be between F and P. Okay, these are the only 6 positions possible. Right? At infinity, beyond C, at C, between C and F, at F, between F and P. Clear? So no need to memorize. It's very intuitive. You just see the diagram and you will come to know what is the next object position. Okay. So what is the next case? Object beyond C. Why are we saying beyond C? Because the distance is measured from pole. So when you go from pole, so it is ahead of C. You get it? Otherwise, when you look from this side, you may say it is okay before C. It's not before C, it is beyond C. Is that clear? This is due to sign convention. All distances are measured from pole. Okay. Now, so what is the first step? You draw the mirror. Then draw the principal axis. Mark pole. Mark C. And for F, you just mark a dot. Complete the ray diagram. So where is the object now? It is beyond C. So object is made like this. So what is this? This is the object. Now what is the size of object? It is AB. Okay, this is the size of object. Again, this distance is measured from B to A. Okay. Now I need only 2 rays. So one ray will be parallel to principal axis. So I will consider this point. Okay, I'll consider this point. Where will it pass from? Focus. Okay, so reflected. So incident direction, reflected direction. Now what about the next ray? So either you can take it from C, it will come here and come back. Okay. Or you can take it from focus and it will be parallel. All these rays, or you can take it from pole and it will come back like this. All of them will cut at the same point. So this mirror has become short. So you have to show both the rays, right? So the intersection after the reflection is at this point. Now you see, what about this image? So this is B dash, A dash. So is the image now inverted?
Yes.
Is it real?
Yes.
So now it is obvious, real and inverted. What about size?
Diminished.
Diminished. ये देखना, ये AB है और ये छोटा नहीं दिख रहा क्या? ठीक है? So what are the three things? Where is image? Position?
Between C and
Between C and F. So first image was found at F. Now all the images will be beyond F. Okay? So between C and F. So image between C and F. Diminished. Size is diminished. And nature is real and inverted. Okay. I said minimum 2 rays. Now, if I would have taken the ray from F, don't draw this. You see, after reflection, it will pass through this only. Okay. Had you taken this ray, the red one, it would have passed through this only. If you take the ray from pole, this too, after reflection, will pass through the same point. Understood? That's why I can take any two rays. So I have taken the ray parallel to principal axis and the one passing through C. So all 4 rays have been used here. So red and green is only for illustration purpose. You can choose any 2 rays. Okay? You see the point of intersection is at the same place. Is that clear? Okay. So I leave it to you which 2 rays you want to decide. The easiest is this and this. Okay. Now what about the next object position? Where it will be? At C. So where should be the image?
At C.
At C. Because now the image is shifting this side. And the size of the image is increasing. So when the object is at C, you will see that the image size is also equal. Same size. Same position, same size. But real and inverted. So try drawing the diagram for case 3. First complete this and then draw case 3. So everybody. तो तुमने सारे बना दिए मैंने बोला तो कोई नहीं Yes, 3 years to try yourself. पहले you forget this. So really, right? यहाँ से ऐसे आ रहा है, यहाँ से ऐसे वहाँ मिल रहा है वहाँ पे Now you see that I have taken all the rays emanating from A. So how I am getting full image? See, basically, this is only a reference point A. यहाँ से if you take 2 rays, यहाँ पे intersect here. You can take next point here, next point here, next point here. 2 rays, and you will see that you will get this line complete. Got it? So we are only taking the reference point. But from every point 2 rays can come, and you will see that the image will be constructed. You got it?
Yes, sir.
Okay? So that's what it is. Yes. Image will be equal size. Intersection का नहीं तो बोला कि मैं तुम्हारा ये सब एग्जैक्टली सेक्टर में नहीं आया किसी का
यस सर
बन गया बहुत लॉजिकल है बन जाएगा पढ़ा कहाँ पे इमेज ये तुम्हारा एक रिफ्लेक्टेड लाइट यहाँ पे है दूसरे का रिफ्लेक्शन कहाँ आ रहा है यहाँ आ रहा है ये यहाँ आना चाहिए तो यू हैव टू डू सम मैनिपुलेशन यू हैव टू एग्जैक्टली रिमेंबर कहाँ पे पॉइंट है ये तो आएगा नहीं तुम्हारा देखो you have to basically use your compass समझो तुमने 5 सेंटीमीटर का रेडियस लेके बनाया तो तुम्हारा C 5 सेंटीमीटर हुआ या 6 सेंटीमीटर तो तुम्हारा F क्या हुआ 3 सेंटीमीटर ऐसे करना अंडरस्टूड तो आएगा तो भी समझो हमने कंपास से ये मिरर बना दिया ठीक है ये हमारा सी है राइट नाउ जस्ट मार्क द पॉइंट डोंट राइट सी फर्स्ट कंप्लीट द रे डायग्राम और सी पे है और ये हमारा मिड पॉइंट है एफ ठीक है ट्रिक ये नाउ यू राइट ए बी ये ए हो गया ये बी हो गया ठीक ये प्रैक्टिस करना पड़ेगा तुमको कंपास लेके रेडियस मेजर करके एग्जैक्टली देन इट विल कम हियर अभी हमारा इमेज कहाँ पे आना चाहिए ये साइज है ना इतना तुम एज्यूम कर लो ये पॉइंट मिल गया ठीक है एज्यूम कर लो बिकॉज वी नो एग्जैक्टली कि उसका सेम साइज आने वाला है और इन्वर्टेड नाउ जॉइन दीस 3 डॉट्स ठीक है नेक्स्ट तुम F से पास कराओ ठीक है और इसको भी यहाँ पे मिलाओ उसका So you have to make logically correct diagram. If you remember the image position, तब तुम बना पाओ
बिना इमेज पोजीशन के नहीं होती
बिना
इमेज पोजीशन याद
नहीं गलत आ जाएगा तुम लॉजिकली गलत हो जाएगा ठीक है नहीं तो तुम मेजरमेंट लेके करो एग्जैक्टली कंपास से तो होना चाहिए आसपास आओ उसमें भी कुछ ना कुछ एरर्स आता ही ठीक है तो अब ये हो गया तुम्हारा F ये हो गया C ये हो गया C समझ में आया कैसे करना है आ गया अभी यहाँ से देख के आया कि पहले ही आ गया
सर मैंने
आ गया आएगा ये वो आएगा
पोल से डाल
हाँ पोल से डाल के लेकिन ये पता होना चाहिए कि भाई इसके नीचे ही आएगा तो अभी क्या हो गया देखो इमेज एट सी ठीक है साइज क्या है सेम साइज एज ऑब्जेक्ट फिर रियल एंड इन्वर्टेड क्योंकि फिजिकली इंटरसेक्ट कर रहा है रियल एंड इन्वर्टेड ठीक है Yes, four. अब तुमको पैटर्न समझ में आया इमेज हमारा शिफ्ट किधर हो रहा है F से C की तरफ अब हमने ऑब्जेक्ट को जब C और F के बीच में रखा तो इमेज कहाँ पुश होना चाहिए बियॉन्ड C समझ में? इमेज हमारा दूर ही होते यार, तो बनाओ इसको, और इमेज का साइज भी इंक्रीज होते जा रहा है। यहाँ पे सेम साइज मिल गया, तो नेक्स्ट क्या होना चाहिए? मैग्नीफाइड, एनलार्ज्ड। समझ में? इमेज दूर भी जा रहा है और बड़ा होते जा रहा है। तो तुमको ये लॉजिक एक बार पकड़ में आ गया तो तुम्हें मेमोराइज भी नहीं करना। पहला इमेज कहाँ पे बन रहा है? फोकस पे, बाद में एफ और सी के बीच में, बाद में सी पे, उसके बाद बियॉन्ड सी, और साइज क्या हो रहा है? बढ़ते जा रहा है। ठीक है, तो ये है पैटर्न। ओके, तो चलो इसको बनाते हैं। ठीक है, अभी हमारा ऑब्जेक्ट किधर है? सी और एफ के बीच में। ठीक है, तो ये हो गया हमारा बी डैश ए डैश, तो बियॉन्ड सी बन गया। नहीं, उसको सी के बियॉन्ड पुश करो। ए बी के नीचे कैसे? वो तो फिर हो ही नहीं सकता, गलत हो जाएगा। तुम्हारा ऑब्जेक्ट कहाँ है? सी और एफ के बीच में है ना, तो ये सी के बियॉन्ड जाना चाहिए, क्योंकि यहां तक क्या हो गया था? देखो, सी पे तुमको इमेज कहाँ मिली थी? सी पे। अब जब ऑब्जेक्ट इधर जाएगा तो इमेज इसके आगे जाएगा, ये लॉजिक है। ठीक है, अब देखो इमेज बियॉन्ड सी, थोड़ा प्रैक्टिस करो घर पे एक दो बार बना के, और पोजीशन दिमाग में बिठा लो, तो तुम्हारे न्यूमेरिकल भी गलत नहीं होंगे, सॉल्व करने से पहले ही तुमको रिजल्ट पता होगा। ठीक है, इमेज बियॉन्ड सी, फिर क्या है? एनलार्ज्ड और मैग्नीफाइड, दोनों में से कुछ भी लिख सकते हो। अब देखो बी डैश ए डैश ए बी से बड़ा है कि नहीं? ठीक है, ये फ्री हैंड डायग्राम है इसलिए थोड़ा ऑलमोस्ट सेम लग रहा है, लेकिन ये बड़ा है, बड़ा है। ठीक है, यहाँ पे क्या है? रियल एंड इन्वर्टेड। ठीक है, सब जगह इमेज कहाँ बन रही है? मिरर के फ्रंट में बन रही है, फ्रंट मतलब रियल इमेज। ठीक है, चलो नेक्स्ट। हाँ, related to this or some related to this? ठीक है, ठीक। स्कूल में किसको किसको ये पढ़ा दिया है? लाइट रेज योर हैंड टिल लेंसेज इट इज डन। तो फिर इजीली आना चाहिए सब कुछ, है ना? अभी कहाँ पे रखेंगे ऑब्जेक्ट? ऑब्जेक्ट कहाँ रखेंगे अभी? एट एफ, ऑब्जेक्ट एट एफ। चलो इसको करो। क्या होना चाहिए? हाँ, फर्स्ट केस का उल्टा है। जब भी ऑब्जेक्ट इंफिनिटी पे था तो इमेज कहाँ पे बना? एफ। अभी ऑब्जेक्ट एफ पे रखा तो इमेज कहाँ बनेगा? इंफिनिटी। ठीक है, तो अभी हम ये कहाँ पे कर रहे हैं? सी की तरफ। जैसे कि हमने हमारा ऑब्जेक्ट है एफ पे, तो ये नेचर ऑफ इमेज क्या होगा? हाँ, रियल एंड इन्वर्टेड होगा। क्यों? क्योंकि फ्रंट में ही जा रहा है। Formed at infinity, parallel line meet at infinity, ठीक है? तो image is formed at infinity. क्या होगा? Size is highly magnified. क्यों हाईली मैग्नीफाइड? हमारा ये तो इतना ही बड़ा है ऑब्जेक्ट, लेकिन प्रिंसिपल एक्सिस से इंफिनिटी पे जाएगा तो इमेज बहुत बड़ा बना, ठीक है ना? इमेज साइज कहाँ से ले रहे हैं? प्रिंसिपल एक्सिस से नीचे, और ये कहाँ जाके मिल रहा है? इंफिनिटी पे, तो बड़ा 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 हो गया, ठीक है? हाईली मैग्नीफाइड। और ये क्या हो गया? रियल एंड, ठीक है? हाँ, ये स्क्रीन पे मतलब वो बड़ा ही दिखेगा, ठीक है? हाईली मैग्नीफाइड मतलब वो इतना बड़ा दिखेगा कि तुम उसको फिगर आउट नहीं कर पाओगे, लाइक अ स्काई। तो स्काई का क्या शेप बताओगे, है ना? हाईली येलो। जब भी एक्चुअली हाईली एनलार्ज मतलब क्या है ना, तुम्हारा आई मसल रिलैक्स्ड होगा, ऐसा नहीं कि ऐप पे रखिए तुम्हें, मतलब जो ऑब्जेक्ट है ना पूरा फुल फॉर्म में दिखेगा, आईज पे कोई स्ट्रेन नहीं है, ठीक है? When the object is infinity means what? A very far away object is treated as infinity. अपना आँख का focal length होता है 2.5. Anything 10-20 times the focal length is treated as infinity. So any far away object you can see comfortably. Okay? So that's the real list.
Are those 2 days parallel?
Yes, these 2 rays are parallel.
So then how is it meet?
This is the thing. They will meet at infinity.
And then no image will be formed.
No image will be formed.
Sir, but they are converging.
They will not.
They will not meet actually, but we say it will meet. Okay? So you need to experience this in the lab. Yes. All right. Case 6. Object between F and P. Object between F and P. So this is the object now. इस केस में you will see that it will form a virtual image. Okay? Why virtual? Because now the reflected ray, so reflected rays so far you have seen were converging at a point. It became now parallel. Now it will diverge. So once the reflected rays diverge, then it will appear that it is coming from behind the mirror. There you go. So one is this. So after reflection, it will pass through focus. The other ray will be other is parallel or diverging?
Diverging.
They are diverging now. So this we have taken along center of curvature. So center of curvature will come back to center of curvature. Okay. So therefore, now what will happen here? So anybody seeing from this side will feel that it is coming from
Behind them.
behind. Now see, this is a virtual image and it is upright, same like object. This is AB. This also is A dash B. So mostly questions come from object at F, object between F and P. Virtual image के questions बहुत आते हैं. ठीक है? So you'll have to practice it to get it right. Okay, so only six object position. Same position for lens. Which lens? Convex lens. Whatever is for concave mirror, same ray diagram for convex lens. With the only difference is the image position will be the behind becomes front, front becomes behind in case of lens. That's the only change. So if you understand one ray diagram, you understand everything. Is that clear? So we have completed 6 ray diagram for concave mirror, only 2 for convex, only 2 cases for convex. So convex mirror में only virtual image is formed. So image convex, so उसका क्या हो गया देखो, इसका लिखो पहले. Image is image behind the mirror. What about the size?
Enlarged.
Enlarged. That is enlarged. What about nature?
Virtual and left.
Virtual and okay, simple. So any more questions about image formation by concave mirrors? Only 6 object position. उसके लिए 6 image position याद रखना है. And the nature.
Sir, my doubt.
What is your doubt? No, you come here. With the doubt. What is it? Is it about numerical or what is it? Talk to me. Is it numerical or what is it? तो न्यूमेरिकल तो भी मैंने कराया कहाँ, उसके लिए साइन कन्वेंशन बताना पड़ेगा. That I have not taught you yet. You need sign convention.
It is taught to in my school, but I had a doubt.
Yeah, but that is a big thing, ना sign convention. अभी मैंने पढ़ाया नहीं तो वो डाउट मैं कैसे सॉल्व करूँ?
आपको पता है?
मुझे तो पता है. अच्छा लेके आ चल. लेंस क्या है, मिरर क्या है? So when is the image larger?
This case and between CNF.
Huh?
Between CNF
Between C and F and
and this case and
between F and T. So 2 cases.
how can I calculate that?
You can calculate it. Huh? So for real image, ये देख फोकल लेंथ क्या है? हाँ गो. This is concave mirror. For concave mirror, what is focal length? Negative. ठीक है? Then U is equal to इसमें क्या देखो आंसर निकालना है, क्या निकालना है?
Exact value of the distance from the mirror
So distance of the
Sir, she has the same number. Actually, it was given to us by our
should be greater than direct, all possibilities. Should be
This is the correct question. 2 times वाला
गलत लिखा है क्या क्वेश्चन?
थोड़ा सा गलत थोड़ा सा गलत 2 times वाला क्यों लिखा है?
Main size. Main size is times object. तो क्या हुआ? इसका मैग्नीफिकेशन तो पढ़ाना पड़ेगा। एकदम लास्ट का वो सही है। मैग्नीफिकेशन is equal to 2. Again, और ये क्या रियल मैग्नीफिकेशन कितना आएगा इसका? रियल माइनस लेकिन मैग्नीफिकेशन क्या होता है? माइनस a by u equal to minus v is equal to क्या होता है? ये रिलेशन आ गया 1 by ये क्या है? रियल रियल के लिए तो रियल के लिए ये आएगा और अगर अनरियल है तो ये तुम्हारा फर्स्ट केस में ये आएगा, ठीक है? तो और रियल इमेज के लिए ये रिलेशन यूज करना और वर्चुअल के लिए क्या यूज करना है? माइनस 3 by 3 इक्वल टू 2 क्योंकि वर्चुअल भी मैग्नीफाइड है तो इस केस में v will be equal to minus 3 ये रिलेशन यूज करना है इसमें तो ये इक्वेशन है एक बार ये पुट कर दिया इससे u भी चला गया एक बार ये पुट ऐसा मल्टीप्लाई करना पड़ेगा माइनस में तो इसमें तो एक बार ये पुट करोगे लेकिन तो बराबर का भी तो सेव करेगा बच्चे निकल के लिए ये u आंसर है ये निकल के लिए u आंसर समझ में आया? तो ये फोटो ले लो या जो करना है ये सब एकदम एंड का है हमारा हो गया लेकिन समझिएगा नहीं अभी आधा अधूरा समझ के नहीं आए समझा? 2 केसेस समझ में आया? दोनों केस समझ में आए? तो आएगा ऐसे आएगा ठीक है ओके विल रिज्यूम इन द नेक्स्ट
बाद में
दूसरा हाँ मेहुल मेहुल जा
मेहुल बाहर जा
मेहुल जा
मेहुल जा
मेहुल जा
भाई क्या हो
बाय बाय मेहुल आइकन पे के है
वो मम्मी का
कोण आहे शेवटला सांगितलं होतं. आणि ते 3 मुलं होते. मग विचारलं. पाऊस आहे का?